All right, let's start section 3.1. Chapter 3 is all about triangles. And 3.1, we're just going to start classifying triangles. So take a look at the picture down to the right here. What shape is it? Clearly that is called a triangle. The prefix 3 meaning, or tri meaning 3, and then angle meaning angle, so it means it has 3 angles and 3 sides, a triangle. To name the triangle, what we're going to do is we're going to put a little triangle symbol, and you can name the triangle by the 3 corners, the 3 vertices. You can name them in any order that you want. So I'm going to call this one triangle G, E, O. The angles are angle G, angle E, and angle O. And the sides are GE, EO, and GO in any order. Triangles can come in many different shapes and sizes. We classify them in 2 ways, once by their angles and once by their sides. Let's take a look at their angles first. So if you want to pause the video and copy this down, you're welcome to do so. To classify triangles by angles, there are 4 options. It can be an acute triangle, where all 3 angles are acute, and you have an example down there below. That means all 3 angles, remember, are less than 90 degrees. It could be a right triangle, where 2 of them are less than 90 degrees, but one's a right angle, so it equals 90 degrees. It could be an obtuse triangle, where 2 angles are acute, so 2 are less than 90, but one of them is obtuse, one is bigger than 90. Or our last possibility is a special acute triangle called an equingular triangle, where all 3 angles are exactly 60 degrees. So when I ask you to classify a triangle by angles, it's multiple choice, it's one of those 4 answers. By sides, there are 3 answers: scalene, isosceles, and equilateral. Scalene means all 3 sides are different. Isosceles means 2 of the sides are equal and 1 is not. And equilateral means all 3 are the same length. So here we have example problems. Number 1 says, name the 3 triangles and classify them by angles. All right, let's start with the big triangle. So the big triangle we're going to call triangle A, B, D. So the 3 angles there are 90, 30, and 60. 2 acute and 1 right. That means this is a right triangle. Now let's take a look at this triangle over here. I know this one is 30, and I know this one is 30, so those are equal. And if you look here, this is a linear pair right here. So to get that other angle, we could do 180 minus 60. And this would be 120 degrees, which is obtuse. So 2 acute angles and 1 obtuse angle means triangle ABC must be obtuse. And the last one, this triangle over here, so we'll call this triangle ACD. We have 60 down here and 60 down here. And up here, this is a right angle, and this is 30. So to do to get that last angle to be 90 minus 30, and this is 60. So all three angles are 60, which means this is acute, but furthermore, since all three are 60, this is an equiangular triangle. All right, number 2. So again, we're going to talk about these same three triangles here. But this is supposed to say classify them by their sides. All right, so let's start with the big triangle again. So the big triangle, we're going to call that triangle ABC. All the tick marks there are equal, so everywhere you see a tick mark, we know those are all 10. So in ABC, this side is 10, this side is 19, and this side is 10 plus 10, or 20. So 10, 19, and 20 are all different. This must be a scalene triangle. All right, let's take a look at this one over here next. So triangle ABD, all three sides are 10, so this is called an equilateral triangle. And then finally, this triangle over here. Triangle BDC, we have 10, 10, and 19. Two of them are the same, so this is called an isosceles triangle. Number 3 is to draw a right scalene triangle. So draw a right triangle where all three sides are different. Okay, there's my right triangle. Let's just make up some numbers for the angles here. Let's say this one is 55, and then to get the last one, remember all triangles, angles add up to 180, so 180 minus 90 minus 55 would equal 35. To make sure that this is scalene, let's give the three sides different numbers. So maybe we can say this is 8, this is 15, and this is 17. So there we have a right scalene triangle. So it says to label the parts for a right scalene triangle. For a right triangle, the side across from the right angle is called the hypotenuse. And the other two sides are called the legs. Okay, number 4, draw an obtuse isosceles triangle. Show it's isosceles by putting tick marks on two sides. Show it's obtuse by making up a number that's bigger than a 90. How about 120? To get the other two angles, we haven't really talked about this yet, but these will also be congruent. So we can do 180 minus 120 to get 60, and then cut that in half. These will both be 30. All right, let's make up some numbers for the sides. How about 4, 4, and 10? I don't like that. How about 4, 4, and 7? That makes more sense. Okay, to label the parts for this one. This angle up here is called your vertex angle. The other two angles are called your base angles. The side between the base angles is called the base, And your two sides are again called the legs. And there you have your obtuse isosceles triangle. All right, for number 5, we have 3 points. I just plotted a random picture of those 3. It doesn't have to be perfect, just so you can kind of see what they're looking like. The problem says to classify the triangle by the measure of its sides. To do this, we are going to use the distance formula 3 times. So let's start by finding the side length AB. So I have the formula there for you. It's x minus x squared plus y minus y squared. So that's 1 squared plus 7 squared, 1 plus 49, root 50. So AB is root 50, which is a little bit bigger than 7. Now let's find BC. Okay, so same formula. X minus x squared plus y minus y squared gives us 7 squared plus negative 1 squared, which is again 49 plus 1, and again root 50. Finally, let's do AC. So AC, x minus x squared plus y minus y squared will give us 8 squared plus 6 squared, which is 64 plus 36, which is root 100, which we should know that is 10. So our 3 side lengths are root 50, and root 100, or 10. 2 of them are the same, which means this triangle is isosceles. All right, number 6. Triangle JMN is isosceles. That means 2 of the sides are congruent. How do we know which sides are congruent? It says angle M is the vertex angle. So this angle is the vertex angle, which means these 2 sides are equal. So we're going to set those 2 equal to each other, ignoring JN for now. Subtracting 2x. Adding 9. It actually equals 4. The question then says to find the measure of all the sides. So take your 4 and put that back in. We should get JN is 2, MN is 3, and JM is 3. All right, last one, number 7. Again, we have PQR as isosceles, so 2 sides are congruent. The vertexes are this time. So I know PR and QR are equal. So let's set those 2 equal to each other, ignoring PQ for now. We get x is 5. So the question does say to find PQ. We're done here. So PQ is 2 times 5 plus 7, which is 17. That'll do it for section 3.1.